Hello all, let's start chapter 2. Chapter 2 is the most important chapter that I see in this book. In chapter 2, we are talking about functions. Believe me, after this chapter, whatever you do, whichever class you go after this, you are dealing a lot with functions. Functions are really important. It's involved in our real life. We have a lot of examples of functions in our real life, a lot. If I start to explain where we use functions, the easy sentence for me to tell you where we use functions or where we can see functions in our real life, everywhere. That will be the easy answer, everywhere. It's really interesting chapter, not difficult. Again, it's a topic that you studied before, some of you maybe, but my plan is to start explain functions from very basic ideas, then we go slowly build our knowledge and we go to kind of study everything about functions, correct? Anyway, 2.1 is basics of functions and their graphs. Before start talking about functions, let's talk or remind ourselves about the topics that we studied before. Let me write an equation here in two variables. Y equal 2x plus 5. In chapter 1, I explained to you that you can any equation in two variables, you can graph it, right? Two variables. It means you have y and you have here another variable x. You can graph these type of equations, correct? Now, to graph this equation, we start with this idea to the easiest way to make a table of xy and choose few values for x, plug in the values of x in our equation, and find values for y. Let's do this again here, right? Let's, for example, plug in 1, 0, -1 in this equation and see how much is the value of y. Let's do this calculation one more time. Then y equals 2 times 1 plus 5. 2 times 1 is 2 plus 5, 7. If I plug in 0, y will be 5. If I plug in -1, it gives me -2. -2 plus 5 gives me 3. Correct? I'm not going to graph it immediately. I want to explain something here for you. When you plug in x1, your y is 7. We name this an order pair, 1, 7. Remember? The first one was the value of x. The second one is the value of y. When x was 0, y was 5. X is -1, y is 3. Correct? All of them are order pairs of what? xy. Now, we call an order pair a relation. Correct? Let's start from here. What is a relation? Let's answer this question. What is a relation? Let's answer this question. What is a relation? Correct? As you see clearly in this table or in this example, a relation is an ordered pair, or you can say a relation is any set of ordered pairs. Correct? Very simple. Relation is a set of ordered pair. Correct? Now, in any relation, in any set, there are two elements or there are two components, right? For example, if I name it general, X, Y, each one of them, I call them a component of this set. Correct? This one is a component, or both of them, I can say components. Right? Now, again, X, Y. The first component in this set, in school, maybe your teachers mentioned for you, we name it input. Or here, the first component, which is the value of X, we call it domain. The second component, which you know it as an output, we call now this one range. For example, if I have an order pair from this example, 1, 7, the domain is 1. 1 is your domain. The range is 7. 1 is what? 1 is your domain. Now, in general, in this example that I did for you, you have 3 order pairs. If someone asks you, what is the domain for this problem? Open a set and only list the values of X, which is 1, 0, and -1. The same way, if they ask you, what is the range? Only list the values of Y, which is 7, 5, and 3. I didn't start with functions yet. I'm just talking, even in your book, they want to just talk first about relation. What is a relation? Because immediately after this example, or after this, we practice few examples about the relations, immediately when I start give you the definition of functions, I will say, oh, a function is a relation. Of course, that's the simple definition for functions. We will talk more about, but the first sentence that I will tell you, I will say, oh, a function is a relation. Correct? It's better to know right now, and I think this will be the last time or the last class that your teacher explains for you what is range, what is domain. Believe me, I'm not saying that it's difficult or why people don't know, but believe me, even in higher classes of math that sometimes I'm teaching, students are struggling to find the domain and range of a given function. And it's really easy, and I don't know why they're still struggling. Just remember this much. Your input, which is the values of X, is always your domain. Your output, which is the values of Y, it's always, we call it what? Range. Correct? Let's do a few examples about this domain, finding the domain and range. Get to know better what's domain and range. Example 1. I'll give you a set of order pairs. For example, 1, 0, 2, 5, 3, 0, -1, 6, -2, 8. I'm asking you in this example, they're asking us to find the domain and range of this relation, correct? Let's just start with domain. I'll just put a D. The domain. Just when you look to, when you're trying to find the domain, always list the X values of the given relation. It means 1, 2, 3, -1, -2. That's simple. That's your domain. Correct? If they ask, okay, what's the range? Just read the values of Y. 0, 5, again 0, 6, 8. Let's list them. 0, 5, again 0, because I put 0 already in my list. I don't want to write it again, repeating, correct? Once is enough. 0 is 0, you have it there, correct? 6 and 8, that's your range. It's really easy to read the domain and the range of these given relation. Now, I don't want to focus too much on relation. Let's slowly learn what is a function. The main topic. What is a function? A function is a relation. The basic definition of a function is a relation. Now, let's specify a little bit this definition. Let me tell you that all relations cannot represent a function. There are a special type of relations that represent a function. Let's put that definition also, or let's put more details in our definition. Which kind of relations actually we call them function. A function is a relation, correct? Such that each element in the domain Each element in the domain corresponds to exactly one element in the range. Element in the range. That will be a complete definition for functions or for a function. What is a function? First of all, a function is a relation. Which kind of relation? That each element in the domain corresponds exactly one element in the range. Let's translate this with the numbers, correct? If I use a table for you to show it in three forms, table, then I'll show it as a set of ordered pairs, then I'll show it as a diagram for you to explain it very well. X, Y. For example, here I have 2, 1, 0, -1. Let's put some numbers here. For example, 3, 4, 3, 6. Correct? Each element in the domain we called X domain. Correct? And we called Y range. Each element in the domain only has one corresponding in the range, one corresponding element in the range. If I draw here a diagram for you, represent this table as a diagram, we call it a Venn diagram. This is your set X, this is Y. And X you have 2, 1, 0, -1. And Y you have 3, 4, 3, and 6. Let's draw some arrows. When X is 2, Y is 3. One element in the domain correspond exactly one element in range. When X is 1, Y is 4. Correct? When X is 0, or why I put 2 times 3 here? I already have 3. When X is 0, Y is 3. When X is 1, Y is 6. Each element in the domain has exactly one element in the range. Correct? Another way that usually I explain functions for my students, I use this example usually in all of my classes to explain what is domain and which kind of relation we call it a function. Look, I'll draw here a road for you. There is a road, right? Or there are two streets merging to one road, like this. One car is driving here and another car is driving here. The question is, both cars are driving. Can both two cars drive at the same time and go to this main road? That's the question. two cars. I'll name this car X, this car X. Can they go to one road Y at the same time? The answer is really simple, yes. Every day when you are driving and you want to merge to freeway, the other cars are coming and you just merge and you go together with them, correct? The answer is yes. They can merge. This diagram actually represents a function. Two values of X can go to one Y. Look at the diagram above. 2 goes to 3, also 0 goes to 3. No problem. Still, it's a function. But now look at this. This is your Professor Ahmad driving his car, right? I'm driving in my car. Suddenly, this road goes to two different other streets, and I'm driving here. Is it possible for me to go to both of these roads at the same time? The only way is that one of my students come with the chainsaw and cut my car and send half of me in this road and the other half in this road. That's the only option, right? It's impossible that this car can go to both roads at the same time. This example or this diagram that I draw, actually, it is not a function. It can represent a function. To see it with numbers, let me draw here two sets for you and show it with the numbers for you. Which one is impossible, correct? Which relation is not actually a function? Again, here you are X, here you are Y. I don't want to write every time what is X, what is Y. X is your domain, Y is your range. Let me put some numbers here. 1, 2, let me write the 2 here, 2, and 3. Here I have 4, 5. 1 goes to 4, and also 1 goes to 5. Correct? Let's put one more number, 6. 2 goes to 4, and 3 goes to 6. Such a relation, you cannot call it a relation. If I erase the others, if I erase 2 and 3, exactly just keep 1, this kind of relation, that one element in the domain has more than one corresponding in the range, you cannot call these type of relations functions. Or in a simple language, when you see repeating X in a set of ordered pairs or relations that they give it to you, and they ask you which relation represents a function, if you see repeating X, that is not a function. It's okay to have repeating Y because repeating Y is this one. But if you see repeating X, it means that's not a function. Correct? Let's show it with examples. Example number 1. Determine whether each relation is a function. They give us, I'll copy this example from your book, example number 2, page 219. They give you a relation 1, 6, 2, 6, 3, 8, and 4, 9, 4, 9. They're asking you to check if this given relation represents a function, correct? What do you do? First, list your domain. What is my domain? My domain is 1, 2, 3, and 4. Your range, but you don't need to list your range, but in this example, even I list my range, which is 6, again 6, 8, and 9. I shouldn't write repeating element there, but in this example, I will write 6, 6. Your focus should be on the domain to know if this relation is representing a function or not. Just check the x values. Do you have any repeating number here? Do you see 1 is coming as a repeating? 1 again 1 or 2, 2? No, there is no repeating x. Then the answer is yes. This relation represent a function, or this relation is a function. Only focus on domain. If there is no repeating x, that relation represents a function. Correct? Another example. Again, a set of a relation given to you, 6, 1, 6, 2, 8, 3, and 4, 9, 4. Is this, I'm sorry. Is this relation represent a function? I'll check only the domain. I list the domain for me. 6, 6, 8, 9. Look at here, 6 and again 6. Correct? One element of x has two corresponding in the y, two corresponding elements in y. When x is 6, y is 1. Again, when x is 6, y is 2. If you draw this diagram here, you don't need to, in this example, I'm trying to show for you why it's not a function. Look, when x is 6, y is 1. When x is 6, y is, again, when x is 6, y is 2. Look, one element in the x goes to two elements in the y. It's the same as example that I explained for you. One car cannot go at the same time to two roads, correct? That's why you call it not a function. Immediately, it's not a function. Correct? Hopefully, by these two examples, I took a lot of time. I talk a lot because I know how much it's important to know what is a function, correct? Because if you don't know the basics of the functions, later we graph these functions, we add these functions, we do operation on these functions, you go to a calculus class, and everything, every topic that we talk in calculus class is about functions. We do the calculus of the functions, correct? If you have like problem with basics, that will be impossible to know other stuff about functions. I'll take a little bit more time to draw another diagram to show you what is a function, correct? Function works. In some books, I saw this example. I like this example. Very bad drawing. Let me correct my drawing. Function is actually like this simple machine that I am drawing here for you. This is your function. You plug in your input to this machine. This is your input or your domain. This is your function, and you get an output. Correct? Look at your calculator. That will be an example of working with functions, correct? You plug in, you press one of the function buttons in your calculator, for example, a square root, for example, raising to a power, one of those buttons in your calculator, and it gives you an answer on the other side on the digital screen that you have in your calculator, correct? Input, output. That's how a function is working. Another example in real life. What you may tell me it's not represent very well function, but believe me, it's a stuff. We are working as a functions. Like, look, the number of hours that you study for this class and what will be your grade in this class. If you put more hours, you get a better grade. There is a relation between the number of hours that you study and your grade in this class. Correct? It's kind of relation. Relation is involved everywhere in our life. Correct? That was a simple diagram that I want to explain to you. What is a function? Function is like a machine. It has input, you get output. Correct? Now, we learned here, if B gives us an order pair, immediately we can find that the given order pairs or relation are representing a function or not. What if they gives us an equation in two variable and they ask us, oh, is this equation represent a function? Then how to answer? By looking to the equation. Can I tell you that this equation, yes, it's a function? That equation represents a function? Then the topic that I want to discuss here, functions as equations. And here we will learn also determining whether an equation represents A function. Let's talk first about the red part, function as an equation. Any equation that you see that's written in the form of y equals something, for example, y equal to x plus 1, or in general, any equation and two variables can represent a function. I put here can, the word can, because some of them, they are not representing a function. They have two variables, but still they cannot represent a function. Of course, the example that I write here for you, definitely this is a function. Later you will know why. Any equation in two variables can represent a function. Correct? X, I introduced to you as an input, or the other name, domain. We call X also in this type of equations independent variable. Correct? Because why we call it independent variable? Because you choose which values for X, right? When you make a table, always it's you that you are choosing which values you want to use for X. 0, 1, 2, 3. Oh no, I want to use -1. That's why the values of X are called independent, because you are choosing. They can be any number that you want to choose. Y, which was your output, and we called it also range. This one, we call it dependent. Why dependent? Because whatever the value of X is, and you plug this value, for example, if I plug in 0 here, the value of Y is actually dependent on the value of X. It's changing based on the change in X. Correct? That's why we call it what? Dependent. These are all the terms that when you are dealing with the functions, these are the terms that we are using when we talk about functions. And I want to today explain everything to you. Why independent? Why dependent? Correct? Now, how to determine that a given equation represents a function? For example, let's do an example and learn how you can do that. Example number 1. They give you an equation, x squared plus y equal 4. And they're asking you to check or determine that this given equation represents a function. How? To do that, remember, to do that, always solve the equation for y. Oops. The equation for which variable? For y. Always solve your equation for y. That's a step one. Let's solve it for y. We have to subtract x squared from both sides, correct? Then y equals negative x squared plus 4, or you can write 4 minus x squared, which way you like. It gives you an equation in two variables, but in the form of y equal to something. Now, how to know that this equation represents a function? Just check by plugging few numbers in the equation using a table, just few numbers, and see if you get repeating x or if you not get repeating y, correct? What I'll do, I'll just plug in here few numbers. For example, I'll plug in x1. If I plug in x1, 1 square is 1, 4 minus 1 gives me 3. Or if I plug negative 1, negative 1 square gives me again positive 1. 4 minus 1 gives me 3. If I plug in 2, 2 square is 4. 4 minus 4 gives me 0. If plug in negative 2, negative 2 square again gives me positive 4. 4 minus 4, 0. I'm sorry, let's list our order pairs. 1, 3, negative 1, 3, 2, 0, negative 2, 0. Do you see any repeating x here? No. But we see repeating y. I don't care about repeating y. If I have repeating y, it's still okay. Two cars can go at the same time to one road. It's like this. 1 goes to 3, negative 1 goes to 3. It's okay, correct? But there shouldn't be a repeating x. There is no repeating x. Okay, then I can say this equation, which is y equal 4 minus x squared, or x squared plus y equal 4, the original one, represents a function. Correct? Look at this example now. Example number 2. X squared plus y squared equals 4. First thing to do is solving for y. Subtract x squared from both sides. Then you can write y squared equals 4 minus x squared. Solving for y, I have to take the square root from both sides. Square root of y squared equals, remember I told you every time that you take a square root, you have to use plus minus sign. Plus minus 4 minus x squared, square root of 4 minus x squared. And your equation is y equal plus minus 4 minus x squared. Now, if you use a table for this example, let's use it and see if this one, I know it's not a function, doesn't represent a function, but let's use a table of values and see if this given equation represents a function. Correct? Let's plug in x0. When x is 0, it means plug 0 here. 0 square is 0. 4 minus 0 is 0. Square root of 4 is 2. It gives you plus minus 2. Even you don't need to repeat, put more numbers to check. Look, when x is 0, y is 2. When x is 0, y is negative 2. 0 goes to 2 and 0 goes to negative 2. Can your car go to the 2 road at the same time? Or in other words, do you see here repeating x? You have repeating x, then this equation cannot represent a function. Or you can say this equation is not a function. This was all about how to understand that a given relation represents a function, or how to find or how to determine a given relation is a function, or if they give you an equation in two variables, how to determine that that given equation is a function. Correct? Later, we will study how to determine if a graph is given to you, the graph represents a function or not. Correct? We will do it later, but still in section 2.1. It's really a long lecture. Now, function notation. Usually, equations in two variables, for example, y equal to x plus 1, the other notation for this equation will be f of x equals to x plus 1. When you change your y to this notation, f of x, we call this equation a function. Equation is written in function notation. F, why f? Because f represents functions, correct? But it's not important that you always use f, always. No, we have f of x. We have g of x. You can name your function anything. H of x, correct? You see here, I'm using x, x, x. This x actually, or this part of your notation represents which variable is in your equation. Let me explain it this way for you. For example, if I have y equal, always not 2x, let's say put something, 3x plus 4. If I want to write this one in function notation, I can use it at f. But what to put here, f of what? I'll check which variable is involved in the given equation. The variable is x, then I'll call it f of x equals 3x plus 4. If the equation was in this form, y equals 3t plus 4, or for example, 3t squared plus 4t plus 1, then I will write this one in function notation form as a f of, which variable is involved here? F of t equals 3t squared plus 4t plus 1, or g of t, correct? Whatever you name your function, but usually we name it f. But at the same time, when you are dealing with few functions at the same time, of course, you have to choose different names for them, correct? The next topic is evaluating a function. This one is also important. You already know it, but I'll explain it again to you. evaluating a function. Evaluating a function means finding the numeric value of your function at a given value or values. Evaluating a function means finding the numeric value of your function at a given number in a simple language or numbers, correct? For example, I have a function f of x equals 2x squared plus 5x minus 6. They're asking me to find or evaluate f of 1. Believe me, I don't know. I'm sharing these experiences with you to actually tell you to focus. It's not difficult, focus. Sometimes the students will say, well, how to evaluate? What does it mean f of 1? Let me tell you, f of 1 means you already did this. If it's not in the form of f of x equal to x squared plus 5x, if it was in the form of x and y, it means when x is 1, find how much is y. Evaluate. In other language, if you want to evaluate this function, if you want to find f of 1 here means wherever, if you change your x on the left side to 1, you have to change your x on the right side also with 1, replace it with 1, and then calculate. This is the meaning of finding or evaluating a function. It's not that difficult to think like 30 minutes, okay, what should I do? Correct? If someone asks you find f of, they give you a function and evaluate at a point, it means replace the variable with that number and just calculate like this. Look, 2 parentheses, x is what? It means 1 squared plus 5 times 1 minus 6. I will calculate this way. Then I can say f of 1 equals 2, 1 squared is 1. It means 2 times 1 plus 5 times 1 gives you 5 minus 6, which is equal. 2 times 1 is 2. 2 plus 5 is 7. 7 minus 6, 1. Then f of 1 is 1. It means when x is 1, y is 1. Because the other name of y is actually what? F of x when you are dealing with function. This is how you evaluate a function. It means replace your variable with the given number and just follow the order of operation and simplify. Correct? Let's do a few more examples. Evaluate. F of x equals x squared plus 3x plus 5. A, we have to find f of 2. B, part B of this problem, we have to find f of x plus 3. C, f of negative x. Looking to this problem, you shouldn't be scared. Whoa, whoa, what should I do? What is this? Easily, I told you, whatever is given, replace your variable on the right side with the given number. Correct? Let's start with A. Let me rewrite the function here. F of x equals x squared plus 3x plus 5. What I'm looking for the f of 2 now. F of 2 means because I replaced x on the left side with 2, I have to do the same thing on the right side. Then this one will be 2 squared plus 3 times 2 plus 5. And I will simplify the right side. F of 2 equals 4 plus 6 plus 5. It means f of 2 equals 15. I'm done with part A. Part B of this problem. Again, I will rewrite my problem here. F of x equals x squared plus 3x plus 5. I want to find now f of what? X plus 3. Look, on the left side, I replaced x with x plus 3. On the right side, I have to do the same thing. Then it will be x plus 3 because I have a square, here a square, plus 3 times x plus 3 plus 5. Now, let's simplify. F of x plus 3 equals x plus 3 square. Hopefully, it should be easy for you to write the answer immediately. If not, use this method, FOIL it, correct? But I know the answer is x squared plus 6x plus 9 because I used a plus b square formula for it, correct? The square of the first plus 2 times the first term and second term plus the square of the second term, correct? But if you do you FOIL this way, you will end up with what I have there, correct? Plus, here I'll distribute 3. 3x plus 9 plus 5. Now I'll combine like terms and I'm done. F of x plus 3 equals, I have x squared, I'll keep my x squared. I have 6x here, 3x here. Here it gives me 9x. I have 9, 9, and 5. 18, 18 plus 5, 23. That's it. I'm done with part B. Part C. Again, the problem, f of x equals x squared plus 3x plus 5. I'm evaluating f of negative x. It means replace x on the right side with negative x. Then negative x squared plus 3 times negative x plus 5. Be careful here. When you are replacing x squared with negative x squared, don't do this. Don't just put the square on the top of the x. If you do this, your answer is negative x squared. But if you use parentheses around, your answer is positive x squared. There is a huge difference here, right? Be careful with that on the test day. Then f of negative x equals x squared. Positive times negative gives you negative 3x plus 5, done. This process that I did for you we call evaluating a function. I will stop this lecture here. I will do a part 2 for this. In part 2, I will cover the graph of a function, how to know a given function, how to know a given graph represents a function, and how to read the graph of a function. Correct? Those are the important topics. Then again, we talk a little bit about identifying intercepts or intercept form of a function. And those will be the topics, and we will be done by with 2.1. But I'll stop it right here, and I'll try to make another video for you to finish 2.1. Correct?